J'avais nommé, je ne sais pas de son docteur nom. Je vais circuler.
Bon, attends,
5 minutes.
Dans 5 minutes. Ça se remplit. Merci.
Alors là, j'ai un problème de chez nous.
It's 9.
Bonjour tout le monde. Hello everybody. This is the Coding for Efficient Network Communications Research Group. In order to accommodate somebody who's on a very short schedule in Hong Kong, we're just going to go through minimal introduction and we're going to go directly into the first presentation, and then we will finish whatever administrivia and other presentations we have. I'd like to thank Nicholas for having nicely accepted to become the volunteer to take some notes. It's greatly appreciated. And without any further delay, again, this is the group that does research into network and application layer coding to improve network performance. We've been going on for a number of years. And for those of you who were there at the beginning, you can see that we have a major move from just looking at codes and coding's library, but also for protocols that facilitate the use of coding in existing systems, and all the research around this, as well as the research that is going on in many other fields that originally didn't have anything to do with coding, but are recognizing the use of coding as something that improves performance, all from network virtualization to video transmission to 3D visualization and everything that needs to have some form of reliability provided by coding. So this is the note well, something that we always have to present to make sure that everybody recognizes issues of IPR and everything. We have a few new people here who have never been at IETF, and this is IRTF follows the same rules as the IETF in terms of recognition of the processes, recognition of the IPR, recognition of how to behave in a meeting. Like I said, we're just going to go directly to the presentation from Raymond because he has a very tight teaching schedule today. Raymond, I'm going to give you the speaking part now.
Okay, thank you very much, Chairman. And okay, my name is Raymond Young from the Chinese University of Hong Kong. The title of my talk is IETF bets for smart lampposts and 5G. Next, please. Next slide, please. Okay. Okay, smart lampposts is a key infrastructure of smart cities, and typically they are equipped with network interfaces, cameras, and sensors, and they promote smart city innovations on a city scale, including intelligent transportation, autonomous driving, real-time surveillance, high-speed Wi-Fi coverage, etc., etc. And it is estimated that over 70 million smart lampposts will be installed worldwide by 2027. And that creates a global market of $8.3 billion US. Next, please. Okay, one thing is that smart lampposts must be connected to the internet backbone before they can become smart. And nowadays, most technologies are one, optical fiber, and two, 4G nowadays. The third possibility that I'm going to talk about is IETF. Next, please. Now, for optical fiber, the pros are it has very high data rate, and it also is highly reliable. Although occasionally, sometimes the fiber can be dug up by people accidentally. Now, the cons are it has high installation cost and very long setup time, and the process is very disrupting, and sometimes it's indeed not possible to lay fiber in some areas. And for example, I was told that in Hong Kong, it can take up to 2 to 3 years to get all the permits for digging up the road to lay the fiber, if you're doing it in the center of the city. Now, so realistically, only a small number of lampposts can be connected by optical fiber directly, and while the rest still need to be connected to the internet by some means. Next, please. Okay, how about 4G? Now, the idea is very simple. You just put a 4G card at each lamppost, converting it into something like a cell phone. Now, the pros is that using a 4G card is that it's very easy to deploy and it's relatively inexpensive. The cons are it has a pretty high recurring cost. Imagine that you have a HD webcam generating like 5 megabits per second of data, and for the whole month you're talking about over 10 terabits per month. Okay? So it's a relatively high cost to transmit all these data through the cellular network. And another thing which make the 4G solution not very viable is that the bandwidth can drop drastically during rush hours. Next, please. So in this talk, I'm introducing the multi-hop solution. In this picture, we have a sequence of lampposts, with the first one on the left being connected to the optical fiber directly. And for the rest of the lampposts, they are connected through a wireless multi-hop networks, which is enabled by BEST code, which is a network coding scheme that we developed throughout the last few years. Next, please. Okay, why do we consider BEST? Now, we know that multi-hop is a long-standing problem in wireless communication in industry, and transmission can sustain no more than a few hops. If you go through a few more hops, then the throughput basically is quite negligible. And sometimes in industry, people refer to this as the multi-hop curse. BEST code is an advanced network coding technology that can sustain tens or even hundreds of hops. And this is done by recoding at the intermediate nodes. And with BEST, a very long multi-hop network can be realized. Next, please. Okay, last year, my collaborator, Shenghao Yang, and myself published a monograph on BEST codes in the synthesis lecture on communication networks edited by R. Shrikant. Next, please. Here's a throughput comparison between BEST and routing. Now, here we are talking about a line network with 20% loss on each, 20% packet loss on each link. So that after one hop, you lose 20%, and the maximum rate that you can ever get is 0.8. Okay. The red curve shows the throughput of routing versus the number of hops, and we see that it's decreasing exponentially fast. So, for example, after 10 hops, you only get about 10% of the rate. Okay, and with BEST code, it is the throughput is decreasing with respect to the number of hops, but it is decreasing very slowly. Specifically, after 50 hops, you still get about 0.7, which is around 87% of the channel capacity or the network capacity. Next, please. So essentially, one can think of BEST code converting a multi-hop line network into a single hop network. The advantages of best code are the following. It has high throughput, low latency, low coding complexity, and low storage requirement. For the last aspect, I'm talking about that you need to store only to keep a very small buffer at each intermediate node. And for all existing solutions, they fall short in at least one of these aspects. Next, please. Okay, for best code, the benefits in terms of operations are it has low installation costs, easy to deploy, and it has low recurring costs, unlike 4G, which you need to pay the monthly fee. And because it's not a public network, you also have guaranteed bandwidth for essential data, for example, post-health check, video surveillance, etc. And it can also cover rural areas not reachable by fiber or 4G. Next, please. Okay, here's a quick comparison with 4G. Both of them have the advantage of a low installation cost and easy to deploy, but BESCO has three other advantages not possessed by 4G, namely low recurring costs, guaranteed bandwidth, and reach rural areas. Next, please. Okay, next I'm going to talk about other applications of BESCO. Next, please. One of them is wireless ad hoc networks. Next, please. Satellite networks. Next, please. V2X. Next, please. Underwater acoustic communication. Next, please. Power line communication networks. Next, please. And 5G. Next, please. There's actually a very close relation between 5G and multi-hop, because in 5G, millimeter wave is used for transmission, which is very directional. And therefore, the receiver needs to be almost within the line of sight of the transmitter. And because of this, many base stations need to be deployed, and relays probably also needed in many occasions. And naturally, many of these base stations and relays will be put on the smart lamppost. Then it boils down to the same question: how to connect lampposts to the internet. And for this, BESCO provides a very natural solution. And in fact, 3GPP has announced that multi-hop will be supported in 5G. Next, please. Finally, I would like to talk about the Hong Kong Smart Lamppost project that our group has been engaged in. So in this project, there's the pilot project, which has consists of the first phase of about 70 lampposts, which is due in mid-2019. And for the second phase, another about 330 lampposts would be installed, totaling to about 400 lampposts in the pilot project. And if everything goes well, then they were planning for a massive deployment of about 70,000 lampposts around the city. And our group has been engaged in this pilot project to apply BESCO. Okay, I also would like to, next, please. I also would like to mention that we have just submitted an internet draft entitled BESCO Coding Scheme for Multi-Hop Data Transport. And this was prepared by my collaborators in the Chinese University of Hong Kong in Shenzhen, and also National Chiao Tung University in Taiwan. Next, please. Okay, so I end this talk with this picture as the take home. Thank you very much.
Thank you. There's a question.
Rick Taylor, Airbus. First off, thank you very much for this presentation. This is really interesting technology. I totally agree with your use cases that just sticking 4G or fiber optic to every lamppost is madness. I have a question about, I'm afraid I haven't read all this in depth and I need to go away and do it. But the picture you have on the slideshow at the moment shows a single linear topology for your multi-hop. Have you done much research into how the topology, so we obviously know lampposts, although down one street, are in a single line, but when you come to intersections, you start to get star topologies. If your one lamppost with a fiber optic, backhaul is at the center of that star, how does BAT scale to look at that, and have you done that research yet?
Well, actually, if the optical fiber is at the junction of the road, it's even better because you can then radiate out into more than one line networks. That actually can multiply. So
there's no sort of congestion on the waveform at that central node that's handling all the communications from all the BAT's connected lampposts.
Well, all you need is a more powerful computer, or you can install more than one computer at that lamppost.
Okay. I think I need to go away and read this in more detail, and I might come back to you on the mailing list. Thank you.
Okay, thank you very much.
Hi, Florin Babrescu, Broadcom. Few questions. What is the distance between the lampposts that you do take into consideration?
Typically, it is less than 50 meters, but the application of the best technology has nothing to do with the physical layer. If they are further away, you need a bigger antenna. That's what it is.
Not quite like this, because the overall link capacity may be dependent on the distance, especially if you consider a wireless medium. So, for example, you may use Y-gig in 60 gigahertz.
Yeah.
Have you considered this one as a possible link?
I'm sorry, what's that consideration?
I was saying, for the interconnectivity between nodes, you may consider Y-gig, which is a Wi-Fi technology operated in the 60 gigahertz band.
Oh, okay. We haven't done that yet, but we are actually looking closely into this possibility.
Also, you mentioned the 5G related work. Currently, there is a integrated access and backhaul that is going on into the RAN 2, RAN 3 groups. Is there any relation of this work to the IAB work in 3GPP?
Probably not at this point. We just began looking. We've just begun looking into this, and so later on we may find some more connections.
Then how can you put the correlation to 5G as long as early since the release 15 and 16 there is nothing to be done with this type of coding?
Oh, because the network coding, I mean, the application of network coding has nothing to do with the physical layer. For example, you can also use it for underwater acoustic communication. It is just something implemented at the transport layer.
Hi, Dave Rand, Network Systems Research and Design. Two related questions about your performance graph curve. Could you put it back up?
Okay.
Well, I can ask it while you're getting it up. Does that graph include or not include hop-by-hop retransmission?
Hop-by-hop retransmission. No, it does not include hop-by-hop retransmission. Because if you do hop-by-hop retransmission, then it is very hard to support real-time applications.
So it would be useful to show a few curves there which relate to loss versus delay of the coding solution versus a hop-by-hop scheme, right? Because there are applications that, particularly with these very short distances, the delay incurred by a single hop retransmission isn't actually that high. And then you also have to build in the slight delay incurred by the coding computation at each hop.
One thing is that if you use for example, end-to-end TCP, then
no, I'm not talking about using end-to-end TCP. I'm talking about hop-by-hop retransmission.
Yeah, I know. And actually, it will consume the. I can say something about our implementation. In our implementation, it actually turn off the link-by-link retransmission. Otherwise, it actually will decrease the throughput.
So does the paper have all this in it? Because I mean, it's useful. You know, you've sort of set up an you know, best case comparison, right? Which is, you know, high loss with no hop-by-hop recovery. Of course, this is going to do a lot better. It would be nice to show it also does a lot better when you use a more conventional layer 2 protocol scheme. And I'm not necessarily saying BATS doesn't do a lot better. It would be really nice if you could show that.
Yeah. Okay. We have done like some experiment, but we haven't shown it in this slide yet.
Okay, so for lack of time, anyway, I don't see no more people at the microphone. Are there any people online on MeetEcho who have some questions? If not, we're going to send Raymond to. Oh,
Just a comment from myself, Vincent. Raymond, you have always been very clear on IPR aspects for all the presentations you've made so far. Don't forget to also do the IPR disclosure for your internet draft.
Yeah, yes, I haven't forgotten that.
I know you will do that, but just a reminder. Thank you.
Yeah, thank you very much.
Thank you very much.
okay, so we will send Raymond back to his class. Thank you very much, Raymond. Thank you for accommodating this presentation with your schedule.
Okay,
And,
thank you very much for the accommodation.
And we will go back to the previously scheduled programming. Thank you so much. Okay, so back to the chair slides. So you wanted to talk a little bit about GitHub. So I'll let you talk about
I wanted
this.
to say a few words about GitHub. So you've noticed that we switched to GitHub for all the research group material. So I already mentioned you in the mailing list this. So do not hesitate to have a look at this GitHub repo. You will find many different things. So first of all, as I said, all the research group material will be posted there for the various meetings, as well as interim meetings. So you will find whatever we are talking about in this repo. But you also have additional repositories in this IETF103-NWCRG organization. You will find the Swift codec. So I will talk a little bit about this later on for the hackathon project. But you will also find 2 additional repos for the moment for the 2 research group item documents. So this is the place where you can find the latest version, whether it has been committed or not, and uploaded or not to the data tracker. So if you want to have a look at the current version, ongoing version, have a look at this. This is the best place for that. And as new research group item documents are accepted, we will create new repository for each of them with a team composed of the authors who will have full access to their own repository so as to be able to update and work on their documents. So do not hesitate. This is the best place to know what's going on in this group, in addition to the data tracker that, of course, remains something important for our research group, like other working groups of IETF. But we have both, and we're working with both. Otherwise, there's nothing new about administrative information. So
so this is the agenda. So we already have gone through one. In the next few minutes of the time we have here, we want to go through a little bit of what's happening with the group in terms of milestones and everything. And then Vincent's going to talk about the hackathon he's been doing. Nicolas is going to talk about satellites. We're going to have a review of the CCN, NDN, and CCN and NDN, and network coding draft next. Vincent has put, actually it is on, you forgot to say this about the GitHub. Vincent has put a number of, we called it FEC for dummies, but I don't think it's dummies. I think it's more for newcomers. But anyway, I don't think people are dumb because they don't know about it. But anyway, and there's a lot of things that explains what network coding is and what network coding can do for you. And I thank all the people who commented on this and sent us like comments and improvements to this. Performance evaluation is something that we've talked about in the past, and Vincent's going to mention it. We have to talk about the milestones. Like I said, for people who have not been in this meeting before, this group has been on for a while. We have gone through a number of iterations through things, and we want to make sure that all the milestones are updated. And we are going, of course, to ask the list to comment on this after the meeting. And I'm going to talk about something that's new that we have a side meeting on Friday, which is in network computing for extended reality. But actually, I think the presentation that Raymond just did, where he had in-network re-encoding, was also showing the improvement that you can have by putting some computing in between endpoints inside a network. And I'm going to be talking about this, and then we're going to talk about, obviously, closing this and see what we are going to do in the future. Next. So we have the items, like now the IDs that are the research group items. We have the network coding and satellite that, again, Nicholas is going to do an update on, and the network coding for content-centric, which is also a RG document, and we are also sharing some of the approval of this document with our colleagues in the ICNRG. We have individual ideas. We have a new idea on BATS coding. We have the generic API. We have the coding for Quick. Coding for Quick has no progress because the Quick guys are so busy putting things together, but we intend to update it so that it won't disappear. And the Tetris and RLNC, who, strangely enough, were the drafts that started this group, have now expired. And this is something that we would like the teams that were behind that to really consider restarting it, as we had talked in the beginning to have the beginning of this to have one draft per type of code that was going to be able to be used. Next. Future meeting, we intend to meet in Prague actually after the winter, I guess it's early spring. And we intend to have the hackathon, and I think this is the next step, the next presentation, but I think we encourage people to show up at the hackathon. I couldn't be there on Saturday, but I think the next hackathon, one of the goals that I would have for Prague is starting to write use cases to test the codec. And so people who know about Python and Python use cases, please show up. And then you're going to talk about the hackathon.
Yeah.
So I think we're done.
Just Okay, so this is a quick update on this, a quick feedback on the hackathon that we had during the weekend, over Saturday and Sunday. That's not what. Wait. No, I forgot something. Yes. Yes, that's much better like that. So a quick update. So the goals of this hackathon was to design a Swift codec, what we call Swift codec, sliding window FEC codec, in order to facilitate tests and experiments by anybody who's potentially interested in this technology, and hopefully to facilitate the adoption of the technology itself, as well as being a reference open source implementation, free open source implementation of those solutions. So that's the first goal of this hackathon. The second goal is to challenge our API, generic API internet draft, and I will talk about it later on. And also it was a good opportunity for me because there was a newcomer at this hackathon project. In fact, I was alone, but I met Kwasi, who's just here, sitting here. And we worked together on this project. And since he's brand new people to IETF, it was a good opportunity for me to test and this FEC and NC for dummies or newcomers, call it whatever you want, and see if it's appropriate. And the feedback is positive, I would say, on this. If you disagree, do not hesitate to interrupt me and show up. but I think it was okay. So those were the goals. We, of course, we did not finish. It's just the beginning of this project, for sure. But we already fixed a few issues within this generic FEC API into the draft. And I updated the document yesterday evening, just after the hackathon, to take this into account. So if you have a look at this new version, you will see many different things. I've reorganized the thing, put some functions in different way in order to facilitate the compilation of the full stuff, fixed a few typos, removed one or two functions and added another one. So those are things that you find quite useful and necessary when you're working the code at the same time as working on the document itself. So that was a very good opportunity to do this work and to have some feedback on this initial draft, even if this is something I wrote myself and with colleagues, and if I was the one doing the most of the correct stuff also at the same time. Even in that case, it was useful. So that's the first achievement. The second one is to, okay, we now have this repository for this Swift codec, and we started to put many different things inside. So we reuse some existing code, either from openfake.org project that I used to work on in the past, but also we also reuse some code, existing code from the Gardinet from Cedric, who's sitting here, my colleague, Cedric Hadji. So you can already find some interesting, not working code, but some interesting code inside this GitHub repository. We focused on the encoder part, first of all, for two reasons. First of all, it's necessary in order to be able to test the full solution. You need to first work on the encoder, and also because it's a little bit simpler. You just have to compute linear combinations of packets to be able to do encoding. So it's something which is quite simpler than the decoder, which has to deal with this linear systems resolution, all this stuff. So that was the first goal. It still does not work, but we are not that far from having a first solution. Of course, we focused on the most simplest assumptions, one single encoder. For the moment, we will extend to any network recording operations later on in this project. We also focused on, well, something that is relatively close to RLC, because this is something I know the best, and it was the easiest way to start the project, but later on we'll try to do something more generic. But we need more MarPower for the next hackathon, so I do insist on this, and you are all invited to join this project, and hopefully during next IETF there will be more people than just myself and Kwasi. If you have C programming skills, because we are focusing on C codec, do not hesitate. It's a good opportunity also to practice. Remote participation is also feasible, even if it is a bit more complex, particularly when you have this time difference, but it's feasible. We have the tools for doing that. Okay, so let's focus on this generic FEC API document. So this is version 04 that I updated yesterday evening. As I mentioned, I moved a few things within this internet draft. I already went through those modifications, but you can have a look at the document itself and the diff with the previous version. You will see that many things moved. Now, I think that we reach a point where this document is not stable, but in a good shape, well, good enough shape to be accepted as a research group item if you believe this is something useful for this research group. So I would like to formally ask for research group adoption for this document so that we can make progress. And in fact, we'll have the two activities in parallel. At the same time, this hackathon project, which is a good opportunity to check and challenge this internet draft, and of course, the generic API internet draft that will explain how to interact with this codec. So if you have an opinion on this, do not hesitate. We'll go through the list, of course, after the meeting to confirm or to gather opinions. Yes, Dave.
Hi, Dave Ranigan. I don't see any objection to adopting as a working group, as a research group item. One of the things I think is a precondition to really getting it to move significantly forward is that there be at least 2 different FEC codecs supported by that API. Otherwise, you can't tell whether you have a generic API or not, or whether you have an API that only works with one codec. So we need to somehow get in the work plan the implementation of at least 2 FEC codecs with this API before we can really decide whether this API meets the goals we've set for it.
Sure. This is in the
I wasn't holding it back. I wasn't going to hold. I'm not saying hold it back from RG adoption, but just make sure the RG has the expectation that it's really not going to get all that much farther until we have at least 2 codecs.
Yes. So a quick answer. Yes, of course, this is one of the goals of this document, to have something generic that can be used by several different types of FEC codes. As I said during previous meetings, we are focusing on sliding window codes, but not only one solution, but hopefully all potential sliding window solutions with end-to-end coding, but also with in-network recoding, as in network coding systems like BATS codes. So we really want to address all those use cases, all those different codes. That's the goal.
Rick Taylor, follow up to that, absolute +1. And can I recommend, I think you sort of answered this already, but that you pick, to make sure your API is generic enough, you pick 2 contrasting FEC encoders, so a sliding window and maybe, I'm trying to pick something else random, but at the other end of the spectrum to make sure that your API is good enough. Just
Sure. Now it's just a matter of manpower to be able to write those codecs and make sure that they are working. So there is also
I
this
think this is valuable,
aspect.
and I'll see whether I can come and give you a hand in Prague.
Okay, great. Thank you. No other opinion? Okay. Anyway, we will ask the question formally on the list.
No, it's fine. And again, I think you've mentioned C, but people like me who are very rusty in C but are pretty good at Python can do a lot of wrappers around things.
Sure.
So,
C as the generic common denominator and puts wrappers on around it. Yeah, for other use situations and use cases and other requirements. Yes, sure. Okay, so we will go to the list and ask the question. And if you want to add some more, do not hesitate. Thank you.
thank you. Alors, prochain, c'est qui? So Nicolas, since I will take notes while you're presenting.
Hello everyone. That will be a very short update on the network coding for satellites draft. I hope you have read it, otherwise this presentation will be complicated because it's just a diff. Basically, we were in ID version 5 document and now it has been adopted, so we are in the first version. We just didn't change the name while going through the working group documents. Adoption, Vincent made us lots of comments. There were lots of harmonization issues in the figures, so we tried to polish all these presentations, figures, and we also had lots of grammar mistakes, and that's something we hope we have improved. Also, there were some, it wasn't clear from the reading what is a current fake usage in SATCOM systems. So we just try to make it clearer by adding 1 or 2 sentences. We hope it's clear enough, but do not hesitate to let us know if it is not. We can point to more DVB-S2 standards, for example, but basically we try to make it clear. Also, Vincent proposed lots of text for the multicast section, so we have tried to include all that, and thank you, Vincent. Such as proposed by Vincent, we added a research challenge section, so we somehow cheated because we moved the conclusion to, we changed the conclusion to a research challenge section. Basically, we have identified two main research challenges that are specifically related to SATCOM and network coding. First one being how to make it deployable today in the systems we have, because that is one of the goals we had in the document. We identified use cases on where we could have good network coding in satellite systems, but there's always a question on how you get it deployed. So we think that this could be doable in TCP proxies we have, because then we split TCP connections. We are at the user space level, so you can do lots of funny things. And we have on the same thing at the terminal side. There's also a challenge that is always inherent to satellite systems in how efficient we are as opposed to how much with radio resource we use. That's an eternal debate and trade-off that is going on in SATCOM industry, and this is even more relevant for network coding in high layers. Because radio resource is scarce, so we have to save it. So that is something that will always be open, and we cannot tackle it in a generic way, just depending on the systems you have and the objective in terms of latency and loss tolerance of the applications. So you have different solutions. Another thing, and now that the NFV working group is over, and I think one of the things that we had discussed, and I think it helps also the API document, if we have to make sure about basically using all the virtualization concepts, make it easier, because we are now speaking about cloud aggregation functions in SATCOM industry, and then we have all these service function chaining working groups. So if network coding turns to be a VNF you could easily deploy, that would be very useful for us, and that would help the deployment of the network coding in satellite systems. Something also that we added, I think we may add some content to it, is a security section, because basically there are lots of SATCOM specific security aspects. But I think the goal of the document is not to tackle satellite systems security issues, more that network coding has any specific issues with security in SATCOM systems. So we precise that in the draft. I mean, we can make some, we have had some, since the document was released as a working group item, we had some feedbacks from the internal, from people from our own company. So we may want to add some more details on SATCOM system security if you want. But I think the scope here is more to focus on network coding. But still, we may want to rework a little bit this section, and also if anyone wants to jump in and has research challenge we didn't think of, we will be open, and we are looking for volunteers to review the document.
Any questions? Yes. Okay.
Hi, Rick Taylor. This is with I'm one of the co-chairs of the DTN working group, which is now IETF.
Okay.
You've got a really good DTN section in this document. I had a quick look. It's really good. Could I ask you to update some of your references to the IETF RFCs? Well, they're drafts still that are going forwards rather than the IRTF stuff. And if you need some volunteers, we're meeting on Thursday morning. Put a copy of this onto the mailing list. I'm sure there are people there, we all work in satellites in DTN as well. So I'm sure there are people with lots of industrial experience who'd be happy to review this. And, I think it's a good opportunity for some crossover. So, okay,
so I will send a copy of this draft to the list and come to Thursday morning's meeting if I have no conflict.
Yeah, thanks.
Thank you.
Any questions on the MetaCo? Okay, so thank you very much, Nicolas.
No,
okay.
Just before you leave. Okay, so I think we maybe are close to the end for this document. So we encourage people to read and review this, and maybe we can also start a research group last call soon in order to get more reviews, hopefully, on this document. So Do not hesitate to have a look and to provide comments to Nicolas and Emmanuel on this.
I can promise we made it short. We tried to make it concise.
Yeah, it's a short document, so it's easy to read. It will take you days. Thank you, Nico.
Thank you.
Okay, so next item is for NC for CCN NDN. Once again, this is a research group item document. So please, Kazu, you have the floor. The rules are working.
Okay, hello, I'm Kazu Samason from NICTA. So let me talk about quick status. The title is Network Coding for CCN NDN Requirement and Challenges. So the main objective of this draft is to provide sufficient information and clarification of requirements and challenges regarding applying network coding into CCN and CCN NDN. So in order to provide established common understanding and hopefully to provide useful insights to developers who apply NC into CCN. So just 1 year ago, we presented our initial draft both network coding research group and ICN research group. And in the previous meeting, it was discussed regarding the adoption of this draft as a research group draft. So then, thanks to the chairs and reviewers, both Network Coding Research Group and ICN RG, this draft has now become a draft of Network Coding Research Group. So here is a current structure of this draft. So this is a Network Coding Research Group draft. So I think we need to I think it's important to introduce the context and semantic of CCN in the section 1 and 2. So in section 1, we introduce both network coding and CCN overview. And in section 2, we provide the NDN CCN background. So currently, in this draft, we provide in section 3, we provide the advantage given by NC and CCN and NDN. And after that, we clarify the requirements and we describe the potential research challenges. So we now cover these requirements as for applying NC into CCN. So one is naming, and the other is transport, in-network caching, and seamless mobility, and security, and privacy. So in this section, we've already modified based on the obtained comments so far. So for instance, we add the relationship between the coding information header and the security envelope. And we add the design choice who determines the encoding vector, and we describe its impact on latency. And we've already updated regarding some editorial updates. So as a potential research challenge, we now cover these 4 points: adopting convolutional coding, later on the congestion control, and the security and the privacy, and the routing scalability. So in this draft, there's no description about a specific protocol or solution because it is out of the scope of this document. So actual protocol proposal will be initiated in another draft. So as the next step, we consider future updates is if there are other other requirements to be considered, we'll add in section 3. And we plan to refine the potential challenges, especially about security routing in section 3. And if any, we may add important potential challenges. So welcome comments, further comments, and suggestion for this improvement. And so we are, as I mentioned, we are now implementing network coding with CCN. So in order to initiate actual protocol proposal. So we are planning to experiment our implementation. For instance, considering the seamless mobility scenario. Thank you.
Okay, thank you, Kazu. Just a quick comment, since you are mentioning it. You have started implementing this, so that's great. We also have this hackathon project. That's great. That is a perfect match between the two. No? What do you think? Would you like to be part of the hackathon team on Swift Code? Okay, we will talk about it later. But you are more than welcome. In fact, we have already been working together on such things in the past, and I would be more than happy to have you in the hackathon team if you have some manpower and time for that.
Yeah. So now we just starting to implement the point. So just at first we want to use firstly make a prototype implementation with a simple module.
Yeah, sure.
Yeah.
Step by step, for sure.
Yeah.
I understand.
Before your question, Dave, there's a number of people who just arrived, and please make sure that you sign the blue sheet. I don't know where the blue sheets are, but please sign the sheet. Dave, you can.
So this is an ICNRG chair hat comment, not a personal comment, which is that we're about to get the CCN drafts published as experimental RFCs. It would be really helpful as you do this work if you discover changes you think ought to be made in the CCN protocols in order to make this work better. Just remember, you don't need to treat the CCN protocols as cast in stone, right? We can change them.
So currently, I think we should not ask to modify any CCNX format which is already in a stage for just before the RFC. So, but obviously, we need to add some packet format change, or we need to change something. But that one can be categorized as something like a extension of the basic packet format. So ICNRG doesn't need to care so much at this moment for the formalizing the CCNX message format or semantics. But in the future, if we have some solution to provide network coding into CCN, we may need to add or modify some part of the defined CCNX format and so on. But this can be done separately.
Okay. Something else? Okay, thank you, Kazu. Anyway, we will have a milestone discussion at the end of this meeting, so we will have questions for you. Thank you. So, a few words about this document. FEC and NC for newcomers, we will say, but I like dummies also because this is a good theory. Anyway, so just to remember you, we mentioned during previous IETF meeting the fact that it was important to have some quick and easy introduction into network coding and FEC to make people believe that they understand what is behind, so that they can more easily accept the technology, and this is something very important for us, for everybody, I would say. So it was a very good comment. So we started thinking about it and trying to put a few ideas, kept as simple as possible. That's at least the goal. Put together some ideas, simple ideas on what we want to address, what is the background, the minimum knowledge you need to have in order to be able to understand more or less what we're talking about. So that's an attempt. I sent on the email, on the mailing list, an email 2 weeks ago on the topic with a draft of ideas. So what I'm presenting now is in line with what I sent on the list, with a few modifications based on comments that I received. I received 2 comments, 2 good comments. People were interested in this topic, but I received 2 suggestions for modifications, improvements. So it's in line with that. It's small, that's a requirement. So I have 8 ideas. So the first one is to stress the fact that we are working on packet loss networks, so networks where packets will be lost, perhaps, or if they arrive to the destination, this packet is does not contain any bit error. It's correct from this point of view. We're not working at the physical layer, so whenever we are we have a packet, this packet is good. So that's the first idea. The second idea is what is meant to explain what encoding means and what decoding means. So encoding means adding redundancy in the packet flow, adding 1 or more repair packets, and decoding means using this redundancy, those additional repair packets, to be able to recover from packet losses. So I think it's quite easy to understand. The third idea is is to tell people that they don't necessarily need to understand what is behind the technology, what is the mathematical aspects. Of course, we are working on finite fields, so if you want to perfectly understand what we are talking about, we also need to know what is a finite field, how we do multiplication, and all those mathematical parts. But if you just want to have a raw idea, a general idea of what FEC and network coding means, you don't necessarily need to have this knowledge. It's not required at all. Just know that you have a linear system. Decoding is just a matter of solving a linear system, and encoding is just a matter of computing a linear combination. So those are 2 basic aspects that everybody can understand very easily. The fourth idea is about FEC codes. So roughly speaking, there are 2 categories of FEC codes. One of them is block codes. The other one is sliding window codes. So block codes, with block codes, you have this flow of data packets. You cut this flow you segment this packet flow into blocks, and you do FEC encoding on each block independently. So that's for block codes. And for sliding window codes, you have a continuous flow of packets, and you have this sliding encoding window, that will slide over this set of packets. And whenever you need to compute a new repair packet, you just do a linear combination of what packets are at that moment within this encoding window. Once again, if you have comments about those ideas, if you believe that they are not put in the right way, if we can have something that is simpler, more easily comprehensible, or if you have suggestions, do not hesitate. The goal here is not to tell you is not to teach you what is network coding and FEC. It's just essentially to get your feedback. So,
Rick Taylor again. Sorry, I'm talking a lot. Just can you go back to idea 2 slide?
Yes.
I completely agree with you, apart from you use the word repair, which if you go to idea 1, you said, we're not a file layer. We don't care about bit error. We're assuming our packets either arrive or don't. The word repair implies that you are fixing broken packets rather than, I think you used the word recover correctly. Can you call them recover packets? You know, you're not fixing a broken packet, you are recovering from an absent packet.
Okay.
It's just an English thing, sorry.
Okay. We also need to make sure that we are in line with the NC terminology documents.
Of course.
So we published. I think we are talking about repair packets in this terminology document. But yes, that's a good point. I will try to find something maybe better, even if it's not fully in line with this document. Okay, thank you. Thank you for this.
And I'm happy with the word dummy because I am a network coding dummy. So
yeah. Okay, so the fifth ID is okay. So what type of code for what type of use case? So basically, very basically speaking, block codes are great for all situations when you don't have so much real-time requirements. So file transfer, that kind of use case is great. For those kind of use cases, using block code is not an issue usually. And sliding window codes are much better for real-time traffic. That's the general idea. Of course, you can find exceptions. You can tell me that, okay, dash over float uses block codes, but this is for real-time traffic. Yes, there are exceptions for sure, but roughly speaking, I would say you can put it this way. Dave?
So this gives me heartburn. First of all, a block code with very small blocks is going to work way better than a sliding window code with very small blocks. So if you have lots of small objects that are independent and you're spraying them out on the network, a sliding window code is actually going to enforce certain types of ordering properties on the data and actually slow things down. So we have to find another way to say this, I think. I know what you're getting at, right? Which is, if you have large bulk data, block codes win.
Yeah.
Right?
Yeah.
If you have streams of real-time data that have time correlation, sliding window codes win. Those are both true statements, but this is going a whole lot further. So I just want to throw a little bit of caution in here that people are going to reach wrong conclusions from that.
Yes. We don't. Well, okay, I agree. No conclusion. That's not the goal. Just give ideas, general ideas. So yes, we can maybe change a little bit the wording for this idea. Yes.
Yeah,
I will try to find something
maybe you
else.
want to add the thing about the size of the data and the timing correlations between them.
Okay, good point. Next ID 6 is about, yes, there are two situations, basically, FEC and network coding. With FEC, we have a single encoder and single decoder, and with network coding, the way we understand it, we have this possibility to do re-encoding within the intermediate nodes. So basically, you have multiple encoders. Next ID 7. Well, okay, there are situations where network coding can help improving network usage. And this is a very simple example with Alice and Bob. Both of them want to send packet to the other one. And you have this intermediate routing equipment, the Wi-Fi router. This Wi-Fi router receives a first packet P1 from Alice and a second packet P2 from Bob. And instead of sending P1 to Bob and P2 to Alice, this Wi-Fi router just sent the XOR combination of the two packets. So Alice, who remembers having sent P1, can easily recover P2 by computing P2 XOR P1 XOR P2. So the result will be P1, and the same calculation can be done by Bob, who will recover P1. So that's a very trivial example. We already talked about this a little bit for SATCOM networks. But there are more complex there are more complex configuration, but this is an idea that is quite easy to understand. Yes, comments?
Rick Taylor again. As a self-professed dummy, that example doesn't show me any improved network usage, because from a naive look, your XOR is the same size as P1 and P2. Where's the improvement?
Yes, but in that case, the Wi-Fi router will send a single packet instead of two packets. So
Again,
it's just
Wi-Fi routers, multicast is much slower than unicast.
no,
So,
yeah.
I think
Yeah.
I'm sure it's a good example. It just needs fleshing out in a lot more detail.
Okay, I can change Wi-Fi router with there's a
Broadcast
two-way
something or other. Yeah.
satellite. Well, yeah,
I think Wi-Fi might be a mistake.
yeah, because yes, Wi-Fi multicast Wi-Fi is not good at all. Yes, that's a good point. Okay, I will change this. Thank you. And final ID, yes, FECN network coding is not necessarily incompatible with congestion-friendly transmissions. This is an objection that sometimes arises. Okay, if you add some more traffic to the data flow, it will make congestion even worse. Yes, but no, we don't do that this way. Of course, if there is congestion, which is a separate problem, then we address this in a separate way by reducing the source flow rates, of course, and so that even if you inject some more traffic with repair or recover packets, it does not make situation even worse. But that's a side problem that can be addressed, and if you do that correctly, there's no reason to say that okay, FEC and NC is not congestion friendly. So that's just to avoid this type of objection. And that's all. So we don't want to have an interdraft on those topic. Well, we may have, but there's no strict requirement for that. What I've done so far is I've extended the GitHub README documents, file in the GitHub repository in order to add those simple IDs in this README and make people more easily understand what we're talking about. So it's already in the GitHub in two repo, in the research group material README file and in the Swift codec README file as well. Okay, so do not hesitate if you have some more feedback to tell us. We will continuously improve those IDs. If you have new IDs that you think should be within this quick introduction to FEC-NC, do not hesitate as well. If you find that the way they are organized is not appropriate, once again, send us a comment. That's more than welcome.
Okay, this is Marie-Jose without my chair hat, as somebody who's implemented some of these things before. I think one thing that you could add to this is the type of packet losses that are experienced, so that so there's codes that are better if the errors are truly random, and what happens when the losses start being correlated. And that, I think, could be something that you could add as maybe not an ID, but I don't know if it's an ID, but yes. I think your slide about the sliding window is not only for the real time and the non-real time. I think the sliding windows or the flexible window or variable size windows have shown better performance when the losses are correlated. So that could maybe, I'm suggesting it, I'm not saying you should do it, but I think a lot of people think that they have a very wrong or a very bad view of what their loss profiles are. And it's not that, you know, I have losses, I'm going to put a code over it and everything's going to go well. Well, it depends a little bit of what this looks like as a profile. So that's my comment. And here's Dave with another comment.
So I think that's exactly right. And I don't think this belongs in the document, but you know, if the reason you have correlated losses is because somebody's using tail drop queues, this is not the best way to solve the problem. Right? Just get rid of your tail drop queues, right? So you have to have a process that's producing correlated losses that's not utter stupidity in the implementers of the network devices.
Okay, nobody else? No. Okay, so let's.
Are there any, actually, also Nicola, just a second. Are there any questions from people on Meet Echo? No. Okay, Nicola.
Just a quick comment on loss pattern. We may have some satellite traces
that we could make available to the group. We
Yeah,
are trying
great.
to work on that for specific use cases to have different loss patterns that are only due to physical layer impairments, not buffering issues.
That would
We
be
are trying
great.
to see what we can do on that.
Yeah, that would be great.
Be back to the group.
I'm actually also working with a startup that may want to let some of their millimeter wave losses, which are not due to stupid, they're due to really millimeter wave. So yeah, okay.
We try to be back on that.
Yep.
Okay, that will be perfect for the next presentation, because in this presentation we're talking about performance simulation, and performance simulation requires to have loss models. So if you have indeed satellite driven loss models, then that's very great, because I don't have any as far as I'm concerned. We have different loss models, but yes, that's greatly appreciated. So you anticipate my comments and my question in this presentation. That's fine. Thank you, Nicola. Okay, so this presentation is about FEC and NC performance simulation. We initiated this idea and discussion in the interim in September. So that's the next talk about, that's an updated talk, an updated presentation after this interim meeting. Okay, in this slide, it's just to mention that this is not the first time we are mentioning the possibility of doing careful performance simulation for FEC and NC. There are at least those two references. One from Morton, if I remember, in IETF 89 some time ago, and another one I made to introduce work on effect frame and the RLC last year. Anyway, so there are several aspects to the problem. There are, first of all, the question of how do you manage your codec? What are the codec parameters? How do you initialize those parameters? How do you, what are the good values to give them, to provide them? So that's the first point. The second dimension is about performance metrics. There are different performance metrics, so you have to select what you want to do, so the right metrics. So there's some discussion about this. There is also a methodology discussion. That's something very important. How do you conduct your performance simulation? And the fourth fourth dimension is about the communication channels. So this is what I mentioned just before, after Nicola's suggestion and proposal to share satellite loss models. So that's something very important, because you want to test your solution, your FEC or NC solution for a given use case. So you need to have a loss model that is representative of this use case. So that's something very important. And of course, this fifth dimension, you need to use tools. So we have this Hackathon project, which focuses for the moment on designing an FEC and NC solution. So next step could be to design tools to evaluate the performance of this FEC codec NC solution in a given use case. So that it could be one, it could be a new Hackathon project after the current one. So that's not a priority. That's not number one, the first priority, but it could be something that we do in the second step. Okay, so I will go through the first four items, four dimensions now, more in detail. So the first topic is about the codec parameters. So what are the parameters and how do you derive those parameters? So it of course depends on the features of the source flow. So there are several possible parameters. So I mentioned some of them now. This first slide is about how do you manage those parameters. Do you consider parameters in terms of, for instance, the window size in terms of number of symbols, or do you express this window size in terms of time, seconds, number of seconds? So whatever fits inside this time frame will be part of this encoding window. So that
those are the two possibilities I can imagine. And depending on the situation, whether you have a fixed rate source flow or variable rate source flow, real-time constraints or not, you will do one, will select one or the other, it depends. So you have to be quite flexible. So you immediately understand that it can be quite complex to do performance simulation in this situation, especially if you are considering windows in terms of time, in terms of how long it can last. Okay, the sample size itself is constant, so that's not an issue. Still for those collect parameters, so you on the encoder side, we have this encoding window size parameter, which is one of the key input parameters. You have the code rate, the amount of redundancy that you put within this data flow. And you also have, in case of real-time flows, this FEC-related latency budget. So that's the amount of time that you can accommodate for encoding and decoding operations. So this latency budget accounts for this time. It does not include the transmission time, the propagation time, the other types of delays that you may experience at the sender or at the server or within the network. It's just for FEC encoding and decoding operations. That's something very important in case of real-time flow, because this is one of the first parameters that will be used that can be used to initialize, for instance, the encoding window size. So at the decoder size, you have this linear system maximum size, and you also have, in case of real-time flow, this is the way I understand it, the way I manage to initialize my parameters, this decoding window maximum size that can be once again expressed either in terms of symbol or time. This decoding window maximum size is the maximum number of packets lost or received that you can put inside your linear systems, while being sure that if you can solve this linear system, those lost packets will be recovered on time within their timing frame. It's not very clear, maybe, what I'm saying, but you won't decode those packets too late to be useful to the application. So this is for real-time flows. So those are the main two parameters that I can imagine for a decoder. There's a relationship between the two. Once again, I don't have time to go into all the details, but this is something we can discuss offline. And we try to explain how to derive those parameters depending on the situation in this document. So this is the RLC effect scheme document that I'm working on in the context of the TSV working group. I'm not fully satisfied by this those guidelines. Maybe we can improve this description. We can find better ways to initialize, or clearly I have the feeling we need to work together on this topic, because it's not easy, it's not trivial, and perhaps we can go and find something or a better way to express this methodology, this parameter derivation stuff together. So that's for the first topic. The second topic is more classic, I would say. It's about performance metrics. Well, there are many different types of performance metrics. The average overhead required to do decoding, to recover from packet losses, the decoding failure probability with respect to the number of packets that have been received. All those metrics are quite classic. But you can also find more practical codec-oriented metrics like the encoding speed, the decoding speed, the maximum number of memory, the maximum amount of memory required for doing encoding, decoding, the number of finite fields operation. If you want to abstract a little bit, instead of working on speeds, encoding, decoding speed, you can also consider the number of finite field operations. That's something that can be quite useful in some situations to compare different decoding algorithms, for instance. So those are other classic performance metric.
Actually, I have another one for that.
Oh.
I would add residual losses.
Yes, that's the next one, the last bullet. It's more or less related to this. This is okay. So last bullet is the required code rate to achieve a certain quality in terms of residual packet loss.
Okay. Yeah, but I think the residual
for a given threshold.
Yeah, but the residual losses are a very good way of comparing different solutions to one another.
Yes, yes, exactly. That's something that we, I fully agree with you, Marie-José.
And this was without my chair hat, by the way.
Yes, me too. We conducted some research on this topic exactly, in this topic. What is the required code rate in order to be able to achieve a certain quality in terms of transmission? And since we are considering real-time data flows, this quality is not perfect, but you have an objective, this objective expressed in terms of residual packet erasures after doing whatever FEC, encoding, decoding you may want. So what is the required code rate to achieve this objective, quality objective, for a given maximum latency? So there is a methodology to carry out this kind of experiments. It's well, I have clear ideas on how to do that, but I would be happy to share with you or others who may have different methodologies, different ideas. So, but yes, that's something extremely important to consider, that we are not always targeting a full reliability, but having a residual packet loss rate can be unavoidable in some circumstances, especially if you have real-time constraints. Next, whenever we have to consider time, it makes evaluation quite complex, so that's obvious. But there's no way to avoid it if you are considering real-time flows. So we have to accommodate this. So the first dimension is about the methodology. How do you do that? You can carry out theoretical analysis. That's quite useful and important. I would never say the opposite, but this document is not about this. We can also carry out real-world experiments. That's once again very important, but the methodology is quite use case by use case specific. Or you can also try to do simulations where with this idea of fully controlled and reproducible experiments. That's extremely useful and accurate. But once again, we need to do that in a careful way because we can make mistakes quite easily. So that's the main focus of this presentation. There are tools for doing that. We have our own tools, made some work on this domain. I would be happy to share with the group. It's already available in parts, but I'm pretty sure that you guys have your own tools for doing that, so we can exchange and share knowledge on this aspect. It can be quite useful. When we are doing simulations, we need to be very careful on the way we carry out those simulations because we must take into account the codec specificities, and the way it's implemented can change totally the conclusion. If you don't take that into consideration, you can easily go into wrong conclusions just because you omitted to think that, okay, if you implement that feature with one output queue or two output queues, that's the example I'm providing at the bottom of this slide. This is for block codes. But depending on the way you implement efficient encoding and block codes, you can either consider one output. Sorry, I forgot to say something. We want to have a constant bitrate output. So in order to achieve this constant bitrate output, you can either use a single output queue or two output queues, each of them of constant bitrate. So it depends how you assign source and repair packets to this output queue or to those two output queues. The result will be completely different in terms of packet ordering in the link, in the connection link between the sender and the receiver, and which will lead to completely different conclusions. So when we are talking about evaluation methodology, when we want to simulate things, we need to be very careful on the assumptions that we are making. That's an example.
it's a bit easier with sliding window FEC codes as far as as far as I know, I would say. But anyway. Fourth, yeah, you're right. With non-systematic codes, you only have repair traffic, so it makes things easier. But non-systematic code is not that useful. It's not that popular, and I'm not aware of real-time systems using non-systematic codes. Maybe I missed something, but I'm not aware of.
We have a framework here.
Yes. This is a framework. Yes, you are right. The fourth topic is about the communication channels that we need to consider. So when you want to assess the performance of a given solution for a given use case, so you need to have a model for your channel, a loss model, and that's typically what we already mentioned today morning, what we already discussed this morning. So it's very important to have traces that are representative of your target use case. So as far as I'm concerned, and so far I was only aware of this 3GPP SA4 mobility traces, which is quite useful, that I've been using quite a lot in the past. It's convenient because instead of having this two-state Hilbert model where you have two parameters, two probabilities, and you have to find appropriate values for those two parameters, which means that you need to explore a two-dimensional space, infinite space, and you end up with some values that are not necessarily representative with your use case. Instead of that, you have those traces that will tell you, okay, if you are a pedestrian walking in the street at that speed, then you may experience either a 1% average loss rate, or 5%, or 10, or 20. But in that case, those are the four loss files. They provide four loss files that explain you what are the packets that will be received and what are the packets that will be lost on the network. So this is the figure on the right. Each dash sign indicates a packet loss. So you can follow this file and see if this packet that has been sent by the sender will arrive to the receiver or not. So depending on the average loss rate, you will have more or less packet losses. And since you are a pedestrian, when you are behind an obstacle, will stay behind this obstacle for quite a long time. And therefore, you will see bursts of packet losses. On the opposite, when you are in a vehicle at 120 kilometers per hour, if I remember well, that's the target of this use case, you will have different loss model. And once again, they provide 4 different files with an average 1% packet loss, 5%, 10, and 20. And you have those files, very convenient use files that will tell you what packets are received and what packets have been lost. So that's something that is available on the web. You can go to this website and retrieve them and use them for your own evaluations. But it's just for 3GPP SA4 evaluations for a specific frequency band, 2 gigahertz, something like that. It's not necessarily representative of other use cases. So this is why I mentioned earlier when Nicolas proposed to share satellite loss models, I was very happy because it's exactly the kind of thing that we need in order to do performance evaluation for satellite communications. We need to benchmark our solutions with loss models that are representative for this use case. And if you are aware of similar loss models for different use cases, do not hesitate to share. We like to get as many loss models as we can, representative loss models, so that we can carry out
do you
experiments.
mean loss models or loss profiles? Because I think, no, because models are usually generated with an equation and models are actually, and profiles are measured. So I'm sorry, I'm playing on words here. So I think we need both.
Yeah, yes, we need both. In case of free PP, this is a theoretical model. So it's a loss model. Yes, it's a loss model. It's a result of a loss model. But yes, there are probably also loss profiles. And if we have access to, if some of them are publicly available, then that's great to share. That would be great to share them. So the idea is to get some feedback, and if you are aware of something, then do not hesitate.
Thank you. Are there any questions?
So wrap up.
I'm sorry, I thought you were done.
Okay, so my last slide.
Sorry.
We're on time. To wrap up. Okay, so that's performance simulation, something very important for the group, I would say. We need to be careful, but of course we are working together and we'll try to do our best. Most probably in that case, we'll need to write a new internet draft on this topic. I think it's useful, chat off, of course. And we need to share experience, whatever work in the domain. Okay. But that's the idea, sharing and trying to find good ways to initialize codecs, to find good ways to run performance simulations and all this. Yes, questions, comments?
Just a comment, because I totally agree about do we need loss models or because it depends a lot on where you are in the Aussie layer, because if you take layer 2 Aussie layers measurements from cellular networks, you'll have all these fake and things already going on. So you have to be really sure about where packet size, if it is measured, what Aussie layer you are in, because otherwise you have to make it clear when you, I don't know, I will try to be clear about when we provide traces on where we are, otherwise we can lead to misleading conclusions.
Absolutely. Okay, so I have a thing about the codec is number one. I think a lot of us, again, chair hat away. A lot of us have done NS3 and NS2 simulation models. And what I think is missing a lot of time in these model is actually good simulation of the codec itself. There's not a lot of very good NS2 or NS3 code simulator. However, there is a lot of, I think, again, us who have done incredible amount of work in simulation, and maybe that could be a hackathon. Is actually maybe not a hackathon in terms of writing new code, but in terms of getting all the NS2, NS3 contributions that so many people have done into some kind of an organized way, so that when somebody wants to do some simulation of a certain loss profile with a certain code, that they don't have to start from the zero NS2 or NS3, depending on what they want to do. So I would actually, again, suggest that maybe in your slides, you could actually add that. So maybe there is some kind of a NS2, NS3 hackathon, because both are very different ID there.
Yeah,
but that's a suggestion.
Yes. Cool.
Questions on Metheco? No.
Okay, so let's continue.
And now, the rest of the time is me. It's like, yes. And là, je suis le. Okay. Milestone updates. For those of you who, again, were there at the beginning, may I recall that, do you know where the blue sheets are, by the way? And whoever didn't sign the blue sheet should actually sign. Blue sheets, sign the blue sheets. Yeah, no, it's in the back. Oh, it's on the, okay. Okay, so whoever hasn't signed the blue sheet should actually sign it. Okay, thank you. So anyway, like I said, we've gone through a number of iterations of these milestones, and I think it's time to review where we are. And also we will, like I said at the beginning, send these to the list also to make sure that everybody agrees with potential changes. So we had all of this that were there. We have some that I think are in pretty good shape. There are things in red that we need to either review, change, or delete, and that's what I'm going to talk about in the next few minutes. So the first one was the existing solutions. We mentioned that both teams, RLNC and Tetris, have let their drafts expire, so they currently are not existent. There's actually the BATS, which is the new ID. So now we have an ID on BATS. We would like to, frankly, rekindle the work on RLNC and Tetris. And so I know that Kerim is on Meetecho, so take that as an action. And Vincent says he can actually help. We would also like the Tetris team to update their draft, and we would like to adopt both of those as RG item. We will also have Dragoncast to update and adopt as a RG. And so we're still waiting for these inputs, and now with BATS, it would be really nice if all these things were updated and be part now of the real milestone and the research group ideas, so that we can actually have this nice set of codes that are relevant to the community. The other one is the NC and Quick that I've been editing with Ian Sweat from Google. Actually, this turned out to be way more complex than we expected because it really has specifications and quick sources and experiment that evolve at the same time as we're trying to pin them down and put a code over it. So that is currently still on. However, there's no way we could finish that this year, and we plan to reschedule it for next year, as Quick, probably in another room right now, are really busy issuing their version 1, and obviously the code will be part of the next version. The draft and satellite, this is almost done. Thank you, Nicholas. And so the proposal is probably to be done by December, just in time for Christmas shopping. And so if the authors can address that, it would be really great. The common API, we also want to reschedule it because essentially, as I think Vincent really showed, is that it was one thing writing about the API and it's another thing about putting it in the code. And so we plan to reschedule it as it's heavily dependent on the hackathon. So yesterday we were discussing about this. We figured out if there is a really good hackathon in Prague, and there's also from my own group of collaborators, there's some people who may collaborate to this remotely. And so I think that by July 2019, we could have like almost a convergence of both the codec and the hackathon and the draft. So this is an interesting thing. We had at the beginning, when we a little bit recharted the group, said, okay, so we should look at some of the adoption challenges. And in effect, it's been done, but not in a draft. It's been done in all the drafts that have been issued about applications, be it the satellite, be it the CCN. They have addressed in there the challenges to adoption, the challenges to implementation. So we think that actually we can give it up, but we're not giving up the idea. We're still thinking that applications of network coding should have something every time you write a draft about, what are the adoption challenges, but it would be like it would be just doing cut and paste from existing documents to create another draft. So we plan to think that this is not very useful anymore. Now this is the rabbit that comes out of the hat. Vincent mentioned this idea that you can actually do network coding or FEC coding that is going to have good performance even within a using protocols that have congestion control. The status of this is uncertain because of other work. I had no time, frankly, to do this. So the status is uncertain. I got in a discussion yesterday with a bunch of people who were interested, but I don't think they also have time. The exact goal may have to be reformulated. I think you missed a line here. No, yeah, we are looking for a champion. We're looking for people who would collaborate to this, especially people who have done it. And the big thing is always how do you deal with essentially all the time network coding with TCP? So I think we'll put that on the list. We need to have more discussions and decide what we want to do with this. Again, there's been a lot of work. There's been new flavors of TCP that have it. There's been all kinds of tunneling solutions that have been proposed. So what do we want to do with this? And maybe we just want to have something simple just to say, okay, frankly, we can't do anything more than what people have done already. We may discover that there's more research that we didn't know. So maybe, again, this is going to the list. The NC and ICN will obviously, thank you guys. This is on track. This is perfect. It will be a small reschedule to make sure that it goes to the last call and actually can again converge to the final version. So the questions is to the authors. What do you think? How much time do you think you need? Or how long do you think it will take you? Because I think this is almost done.
So I'm Kazi Samson. There's still remain item to be written. So maybe we perfectly will make a complete draft version up to the next
IETF?
Next IETF. So
okay.
So
you would be ready by spring 2019.
But I don't know. It's too late, or when should we complete?
Well, I think the question is back to you: is when can you do it, and then we will accommodate the when you can do it. So. If you think that by Prague you will be ready for this last call, and then we put it last call in Prague, we're fine.
Okay.
So do we do that?
Yeah.
Okay. I'm good. We had talked about looking at network coding and robust tunneling. A bunch of people were interested in this. I think we abandoned it. And the proposal is to take it out as a milestone because, again, this is now part of specific implementations to every code that has been proposed. And I think even, Nicholas, you address it into the satellite. So maybe it is something that has now been embedded like the other ideas. Some of the other ideas have been embedded into other people's work. So we think that we could remove it. It's not a real milestone anymore. And then the question is, do we still want to do tunneling? Well, probably yes. So new milestone. We have the Swift codec, which is the hackathon project, and I think that should be part of it. I mentioned that it's also related to the API document, and we think that July 2019 would be a good time to have at least a very good first version. Assuming that all C programmers in this room show up in Prague and Python who want to do other things. The new milestones maybe that we want to add, this forward error correction network performance evaluation. If Morton and company are interested in the draft and if other people are ready to collaborate, and this has to deal again with loss profiles and everything. There's this idea of the computing and the network for network coding. Actually, there's some people on the list who have said that they had started working on implementations of network coding in P4, for example, so that it would be inside switches. And Dave, you have a question?
No, I think this is great, but there's a possible confusion in the wording. which is you can mean one of two things. One is how to use in-network computing to implement NC and potentially recoding for NC.
Yeah.
And the other is how could NC help a computing in the network architecture?
Yes, that's fine. There's
And-
both.
Well, I think those are sufficiently different that people will get really confused if you try to make one
No,
thing that's doing both.
No, I'm saying.
There's two separate things.
It's two separate things.
Great.
There's the P4 network coding, which is how do we re-encode stuff inside the network. And then there's what I'm presenting in 2 minutes, which is what can network coding do to help things that are computed in the network or the application. So that's two things. There's one is helping and the other one is actually you doing it. So we'll see. The idea is that we wait some more and we'll see what happens. And I would say for me personally, I would say probably the performance evaluation could be actually a very valid milestone because of what is needed and because also of of the coding for dummies, which has defined what things are, and then having this thing is how do you evaluate the performance could be really well. The computing in the network, the reason I'm not pushing that much in this group, it's because we're trying to start a new group, which is not what I'm going to talk a little bit about. Questions?
Hitoshi Asada. I'd like to suggest you to add one milestone. It's related to network coding with ICN as a solution, because currently it's just defined a requirement and challenges. And the most important, I don't say most, but one of the most important point is that how we express the network coding function within an ICN or CCN network. So this is really important issue to formalize the packet format. And again, we may have some collaboration with ICNRG, but anyway, it's good. So if this research could initiate this kind of work, it's perfect.
Great, thank you very much. Well taken. Okay, so I'm still on, I guess. Et puis on est là. No, but I'll be fast the next one. Okay, so for those of you who were at the ICN RG interim yesterday, this will mean it will sound like stuff that you've seen before, but let's go on to do it. And by the way, this is the picture is from Magic Leap, who actually made their name by showing this picture. It's actually with goggles of a whale that jumps out of a basketball court. So there's a draft that I wrote about the review of what I call the requirements for what I call extended reality. For me, extended reality is actually trying to find the commonalities between augmented reality, virtual reality, 360-degree video experiences and stuff. And the idea, because we are suggesting the creation of a new research group on in-network computing, one of the idea was actually to see once you have networked XR experiences, what are the challenges and what is needed in terms of adding computing in the network to be able to meet these requirements, and also to look at some of the open issues and the research aspects, and a lot of them have not been resolved yet. So the idea, and you'll see that I've put packet loss and loss-induced delay here because this is this research group, but a lot of other things are there. So it's the multi-source, multi-destination problem, where you have a lot of sources for your experience being part of an IoT, some video, some overlaying graphics, a lot of things that are bringing together, and they come from different sources, and they're going to different destinations. And especially if you do it in a multi-party and that everybody is participating into that experience, then you get a lot of interesting networking challenge. So it's this shared experience, it's interconnected, it's distributed, you need some federation. And so you're creating this global immersive experience. And so some of the principles is allow joint collaborating in XR. One of the best one I saw was actually joint surgery, joint manufacturing. IKEA actually has a very cool augmented reality things where people are building tables and chairs in AR. So the multi-view also, like when you start looking at it for a different point of view, and all the extra streams. And also that becomes also another issue, is that some of these streams are very, very large streams with very large bandwidth requirements, and some of them are very small, but they're the ones who actually are driving the experience. So the challenges, and thank you, Dave, for suggesting to take the word that was there. So it's actually, the challenges is on-time delivery of all these multiple streams and their rendering across multiple participants. So you want these things to happen at the same time, because if these people are sharing, they have to share together. I will tell you that I have experience of something that we used to call social television, which was also had a thing about having people were sharing the same video experience. And it was a big thing of having them having it at the same time. And actually network coding helped in that. Obviously, a lot of these streams that are coming have a lot of sensitivity to packet loss and loss-induced delay, especially, strangely enough, for the non-video components. If you're going to have something that's overlaid and is graphics, if these things are delayed, then the whole experience falls apart. Or if they're lost, it's even worse. So at low end-to-end delay and delay variations, it is very well known that when things in immersive experiences are delayed and that you move your head to try to see them, you get seasick because your brain expects the experience to move with you and it doesn't. And obviously, this is also idea of optimizing the cache and the rendering. This is actually inheritance from gaming. The gamers have started doing that. You start putting elements in the network that will not change, non-variant elements, and then whatever is the activity, the dynamic stuff goes over it. But all of this is part of the experience. So what would we like to have? This is actually, I've just figured out this is extremely busy. So you would like to optimize the location, the type of resources that you want to have. You would like to distribute the functionalities between data center and edge. This actually requires functional decomposition of some of the elements. Again, I said there's some things that are really well done in the core, in the cloud. There are things that cannot be done there, which are the things that really happen now. You may want to have federations of these edge nodes. That goes back to the idea of how do you distribute the functionality and how do you distribute the load across all these things. And then the evaluation, again, that's actually from the gaming world, the local caching, the micro data centers with some of the pre-rendering that is needed for the experience. You may want to have multicast distribution. I don't know why that is in bold. Anyway, and again, one of the things that I think is interesting here, if you have this idea that you are going to put things in the network to help these things, to help these experiences, is that it's not about just putting it in the cloud, which was what people thought in the beginning. It's not just putting it in the edge, because this is also not the thing, and it's not just putting it in the middle. It's everywhere. And so you can actually also think of trend and machine learning-based congestion control. There was actually presentations at the ICCRG in London about that, and it was very interesting. You want to have dynamic allocation of all the functionality as people move, as the group changes, as the experience evolves. And you may want to have performance optimization. And then we go back in some of the things that we talked here on tunneling, solution virtualization, and loss protection. And so I will not go into this because we will not have time, but this is essentially the architecture, or one of the architectures. And I made it very complex to actually highlight that a lot of these things, although there is ICN in there or CCN, there is in the network computing that helps some of the fake functionality. Coin, by the way, is for computing in the network. There are things that come from the cloud and interact with the cloud and go back to the cloud. I think a lot of time that I think one of the mistakes of all these architectures is you have the cloud, you have the transit network, and you have the destination, not thinking halfway that there's interactions between things come to the cloud, are processed, go back to a cloud, go to the network, and when they come to the edge, they have to actually net synchronize with incoming streams that are coming from other parts of the network. So I think this is what I wanted to highlight in that. What's the link to this? Network XR is obviously very delay and loss sensitive. We want to use erasure coding to provide this packet erasure coding to maximize things like related to peer-to-peer and multipath efficiency, and reduce the need for retransmissions. Actually, you want to prevent, if, as much as you can, to have retransmission of the lost information. You would like to recreate it. And it has to it really has we were mentioning this right now, the link to current in-network computing and programmable network elements. Once you can actually program in the network elements to facilitate the streams that facilitate the fact that the streams need to have very low loss and very low delay, you're going to be very happy with this. So there is a strong link to this group. However, there is going to be a request, actually I request comments from both the computing and the network, which does not exist, and the network research group community, and I would like to have co-authors from the XR community. I've actually reached out to people who actually develop some of these things. We intend to generate a V2, and this is a typo. Actually, I wrote this when I was at V0, figured out that the XML compiler had eaten half of my draft, so I had to put a new one. And eventually have it adopted as a CoinRG if CoinRG ever happens, because join us for Coin on Friday. Coin is actually it's not even a proposed research group right now. Coin is a proposal for a proposed research group well, it's like the pre-proposal. Anyway, so it's a proposal for a proposed research group. We're meeting on Friday. My co-chair is in the back there, Jeffrey from Huawei. And the idea is to look at the whole research that is happening right now in computing in the network, both in the data center, at the edge, and again, like I said, in the middle. A lot of the work is research of what you called things that are in the network in terms of how they reprogrammed. But because of my own interest, I also think that we will look at some of the applications that are enabled once you can do that, and then can justify all the other implementation. So again, join us Friday. And for this group, I think there is a strong possibility for FEC and network coding to basically be part of one of the great XR solutions. Thank you.
Thank you, Marie-José. Is there any quick comments, questions? We're on time. We have 2-3 minutes left.
Well, we can conclude.
Or you conclude. Okay, so.
Well, thank you everyone. Merci beaucoup. La prochaine fois, on fait le meeting en français. You should have known, for people who came in late, for the first 5 minutes of this meeting, everybody was here everybody spoke French. So thank you very much. We will see you in Prague. We will see you on the list. And I can see that there was a lot of new people here, and this for us is absolutely fantastic. Please collaborate. This is a great topic, which I think maybe has taken some time to take off, but I think that it's right on for so many of the new network applications. Thank you very much.
Thank you, everybody. See you in Prague. Just on time. Perfect.
On fait des bons meetings. Oh, thank you so much. Il y en a deux. On a 2 pages. Et on n'a jamais eu tant de monde. Thank you to everybody on the Meet Echo, by the way. Thank you so much for your participation. And I know that a lot of you are at, in the middle of the night, so thank you so very much. Hello, Mr.
I don't know if your ears were working, but I've been covering FEC stuff for TSP. So interesting. I wasn't paying attention to you, except that I was paying attention to you. So, please check that out.